Okay, let's do an example of correlation with the stats calculator. Now, this works pretty much in the same way as the TI calculator, but of course everything's just slightly different, but not that much really. The thing to keep in mind when you're using the stats calculator here, you have a list editor, and you just click into it here, and it works just like the TI calculator here, so just like a spreadsheet. And so you insert your data. I'm going to go ahead and type this data in. Let's see, we've got 50, 75, and I'm taking care to put the data that is my independent variable in L1, and then I'm going to put the values of the dependent variable in L2. So that would be the 76, 61, 64, 71, and 58, and 60. All right, so generally speaking, these data sets are labeled X and Y to tell you which one's an independent variable and which one is a dependent variable. All right, but here you can record how much time you spend doing cardio each week, so the number of minutes that you spend doing cardio, but you can't really control directly what your resting heart rate is. It's just kind of affected by other things going on in your life. So we're trying to see if one of those things is how much cardio you put in. Okay, so once that data is in the lists here, go back to the calc screen. And in order to do linear regression, there's a button actually here for linear regression. You just hit that. It brings up the name of a function. And all you have to do is just type in where your data is. So you had the X data in L1, the Y data, so the dependent variable that is in L2, and then just press enter. And it comes up with a lot of different information here, but the most important stuff, firstly, would be R, which is our correlation coefficient. So we have R equals negative 0.833. That's my correlation coefficient. And that right there is a pretty good correlation coefficient, but we're not totally certain that there is a very strong linear relationship here because, number one, this really is a small number of data points. So to know for sure, you really need to do a hypothesis test. And that hypothesis test always looks like the form, the null hypothesis is rho equals 0. The alternative hypothesis is rho not equal to 0. So rho is the correlation coefficient for the entire population. And so it is either equal to 0, meaning there is no statistically significant correlation, or it's not equal to 0, meaning that there is. All right, so with R here, our sample correlation coefficient, we're not really certain. But we can calculate a p-value, which the calculator does for us. So the p-value in this particular case is listed as 0.039. So 0.039, that's the p-value. And we do with it just like in any hypothesis test. So we would compare it to a level of significance. So perhaps if the level of significance of this problem was 5%, we would say that the p is low, so the null must go, meaning that the null hypothesis gets rejected, leaving the alternative to be, basically the true statement, meaning in this case that there is a statistically significant relationship between the data. And when that occurs, it makes sense to go ahead and form the linear regression line, or I should just say line of regression. Anyway, and the stats calculator here has already provided those values for us. If you'll notice at the top here, it says y equals ax plus b. So this is the form of a line, just like in an algebra class, but usually that was mx plus b, although the names of variables don't really matter that much. You just substitute in the value of a and the value of b that are provided. So a is negative 0.19, so this would be y equals negative 0.19 times x, and b is 78.12, so plus 78.12. And that right there, that would give us the line of regression. And we could use this to make predictions for other resting heart rates based off of how much weekly cardio somebody's putting in. And that's how we do basic linear regression using the stats calculator.